Okie dokie, we are on lesson 81, and it is called tessellations. Go ahead and say tessellations. Tessellations, alrighty. This starts on page 526, and it's a lot of reading. Not really any examples, but I will do lesson practice with you guys, and I encourage you guys to try these activities, one of these activities, maybe both. You should get a cool art piece out of it. So this says, archaeologists have found that people use tiles to make mosaics. So if you've ever seen a picture or something, it's all these tiles put together to make a bigger picture. That's called a mosaic. To decorate homes and other buildings as long as 4000 BC. So they've been using tiles and shapes to make bigger pictures for a long time. Kind of like when we did our Georges Seurat artwork, where we did the dots for the Space Needle. Kind of like that, but people use shapes of different colors to make a bigger picture. So the Romans called these tiles tessellae, from which we get the word tessellation. A tessellation is also called a tiling. Is the repeated use of shapes to fill a flat surface without gaps or overlaps. Below are examples of tessellations and the name of the shape produced on each one. We also might see it maybe in kitchens or bathrooms or the floor when we put tile down. Lots of things are just shapes over and over, like squares. This is a common shape that I've seen for kitchens, for like the backsplash that goes against the wall. So some of these things you might see in your daily life. So we got triangles. All of these are triangles, and it makes up this lovely pattern. Or we have hexagons, which means it has, hexa is 6, right? 1, 2, 3, 4, 5, 6 sides. So it's got 6 sides and makes this honeycomb looking shape. And then we have quadrilateral. Remember, quad means 4. So all these are, from here they look like diamonds. If you turn your head a little bit this way, they're squares, but they're 4-sided shapes, and they make a quadrilateral. So starting with any tile, how might you move that tile to continue each tessellation above? That is, what transformations can be used to go from one tile to another? So transformations are kind of those flip and slide, and slide, flip, and the turn one. I don't remember what the fancy words for those are. So if you need to know those fancy words, I forget them too. You can always go look them up in that chapter, which I don't remember which one it was. Alright, for the triangle tessellation, rotate a tile 180 degrees, then translate it up, down, right, or left. So we would take one triangle, we would turn it 180 degrees. So if we were going to, let's see, make it here. If we had this triangle here, and we wanted to continue, so that's kind of like what these are. Let's see, hold on. This is kind of how it is, right? So if we wanted to continue up here, we would turn this 180 degrees, and we can make it go up. I think up is probably the best, but you could turn this 180 degrees and make it go, so this would go upside down that way. You just turn it upside down that way, and that's how you'd get another triangle. So you turn it 180 degrees and translate it however you want it. So this one, you turn 180 degrees, and then there it would be, upside down. Sorry, my marker is dying. I don't know what's going on with it. For the hexagon tessellation, translate the tile until one of its sides align with the other sides of the hexagon. So here's, let's see, my hexagon. So I would just, let's see, this is kind of how, they meet. Is that right? No, that's not right. They all meet out their angles. So then this would be another one kind of like that. That one's huge. but you would just turn it till the next one. So I would just turn this until this angle would be here, and then that's how I'd get that side, sorry. And wow, that's terrible. I try my best. It's not beautiful, but you would just turn it and flip it to that from that side so it touches that side. So you're just kind of turning things. And then for the quadrilateral, you'd continue the pattern. You can go up, down, left, right, diagonal. You would just continue. You take that, and then you don't really have to turn it because it's the same shape every time. So you just copy, paste, copy, paste. These ones are like copy, rotate, paste is how that goes. But it also says not all polygons tessellate or fill a flat surface. However, every triangle and every quadrilateral, so everything with 3 sides and 4 sides, can fill a flat surface. Here we show 2 examples. So here we have a triangle. It's got 3 sides. Ready? I'm going to use my pencil again. We got 1 side, 2 side, 3 side, and that would make another pattern. So it might not be, you might not be able to turn it to make this pattern, but it still makes a nice pattern. Oh, these ones tessellate. So triangles, you'll be able to flip it, and you'd still have the blue is the same as the white, just flipped. And this one, although it looks like a triangle, it's actually a quadrilateral because we have 1, 2, 3, 4 sides. So that's kind of like a nice stamp that's even on both sides. So you can stamp it, turn it around, stamp, turn it around, stamp. And as long as it has 3 sides or 4 sides, it will always be, it will always tessellate. However, every triangle can fill a flat surface. So we can always fill the shapes and have no kind of extras with triangles and quadrilaterals. Alright, this activity says to kind of cut out, oh, it says on lesson 30, activity 35. So, probably can't do that one since I don't have that. But you can kind of cut out your own shapes. So what you can do is cut out like these shapes on a piece of paper, make a whole bunch of them, and then see how you can connect them to make patterns. So you'd want to have the same shapes. Maybe you get different colors. Maybe you can probably just draw these things out and color them different colors. I would say cut them out though, so you can see how they turn and rotate. But it might be a fun activity if you can cut these out and make them make patterns like these. So cut out some shapes and try and make patterns like those. It might be a fun activity for you. Alright, lesson practice says to trace this figure on your paper a few times, turning your paper as you trace to show the figure will fit a flat surface. So this means to just trace it and draw it a few times on your paper as you trace to show the figure will fit to a flat surface. So I'm going to go ahead and draw this, draw it down here. Yikes. Let's see if this one works any better. Not at all. What the heck? How about this one? Oh, much better. Alright. So, we have a shape like that, and now I can turn my board and draw the same shape right there. And then, let's see. I can't really draw the same shape there, but I can continue to draw it there. And then, oops. This isn't even. Let me try and make it even. I can draw the same shape there. So it doesn't fully make it even, or not that way. I could do, ready? Here we go. And then I could do the same thing up there. And then, let's see. Do that, and then, oops. Do that. So you can make kind of a nice pattern, which that would do that and that would do that. I think that's what they're wanting. So see how these ones kind of go out like a Black Widow thing, and these ones kind of go in like a hexagon. So I think that's what they're wanting. So it does tessellate, and then we could flip that over and continue. So ignore that. That was not a good example. And then it says, does this figure tessellate? Which we have a pentagon, which we have, oops, terrible. Which we could kind of turn just like a hexagon, like these ones, and just kind of turn it on its flat surface, but it won't come out quite like this because these have an even amount of sides, so it'll fit quite nicely. Now, I know triangles don't have an even amount of sides, but the 3 sides make them tessellate easier. This one, if I took this as one side and did that, I don't think it would come out right. See, because then I'm trying to do 5, my 1, 2, 3, 4, 5 sides, and it doesn't come out right. It's very hard to draw them all even though. So I'm gonna say no, it doesn't tessellate, but you know what, let's look at, yep, I'm correct. Because it's not gonna be even. It's not gonna, like how this one makes a nice line and you can flip it over, or this one would make a nice pattern and you can kind of copy paste. This one you can't copy and paste and rotate it and make it a nice pattern. Alrighty. I'm gonna, let's see. Letter C says to look at the 3 shapes below, find pairs of shapes that will tessellate. Make a list to show the combination of each pairs of shapes. We're not going to do that when we have this again in the future, and hopefully you'll have it more next year. It's easier, it's more of a hands-on kind of thing to see, which we can't do. So I know it's kind of confusing. It's important because it's showing patterns, and you can use math to figure out the patterns. So it'll be important in the future, but right now it's hard to do it without hands-on kind of activities. So just bear with me on this lesson, and we will just continue through the work, and when we have stuff like this, I'll make sure I do it with you, because I know tessellation might be a confusing word, but it's just kind of making patterns and making them all even and equal. Some things aren't even or equal. So that's what this is about, and it's going with rotation. So this type of math goes more with artwork and kind of making buildings and tiling and stuff like that. So it is important. It's just hard to do from home at the moment. So let me know if you have any questions.